Hey guys, good evening. Good evening. Welcome to Cat Ninjas. Welcome. Good evening. Good evening. So, if I'm audible clearly and you are able to see the screen, why don't you give a quick confirmation that we are good to go? Good evening, everybody. Good evening. Good evening. Yeah. So let's get started. We are doing something on probability. So we'll continue our discussion on probability side, permutation, combination, probability. In fact, it all goes together. So counting we learn in permutation, combination, and then we'll try and apply this with respect to probability where we understand the event and we try to work with that particular event. So before we start, let me quickly introduce myself. So if somebody is new on the platform, here is my introduction. I'm Belvi Srinivas. So I've been working in this industry since 2007. That's about 14 years now. And I worked in various capacities with various organizations in those 14 years. And I did develop some good skills to train the students effectively in the area of QA, TI, and LR. That's briefly about me. Yes, so how do you reach out to me? So that you can join this Telegram channel. And if you have any short concerns, the short messages can be sent on this or quick questions can be posted out here. So that not only there are many active students who can also kind of try to address some of your concerns. If intervention is required, I will chip in. I will also try to address some of your concerns. That's how we can kind of reach out to each other. Quick announcements before we get started. So Unacademy offers two kinds of subscription plans. One is Iconic, the other one is the Plus. Plus is the basic plan, the Iconic is advanced plan, which means it has more features. So in the Plus, you do get exposure to structured courses, various kind of structured courses. Structured courses, when I say you may be looking for the course for SNAP, you may be looking for NMAT, you may be looking for a course specific to IIFT, that, or you may be thinking that I'm weak in one particular area, maybe DILR, so there will be structured courses on DILR to take you from one level, right? Likewise, some of you may want to explore the depth of the matter, so there would be topics related with the depth of algebra, or it can be to the depth of arithmetic. So likewise, depth of RCs. So likewise, different kind of structured courses would be run by different educators on the Plus platform. That is what we mean by the structured course, and you get substitute study material, the weekly test, live classes, etc. That's what you get in the Plus subscription. Iconic subscription, in addition to whatever I have said so far, you also get the opportunity to speak one-to-one with the mentors, educators, or with your favorite educators. With you can set up the meetings, brief meetings you can set up, and in the meetings you can discuss over the voice, you can discuss your concerns with respect to the topics, or it could be with respect to the study plans, it can be with respect to the score improvement in the test, it can be with discussing your strategies, how you are attempting your test, or it could be even with respect to the interviews and various other things, right? So I'm just telling you what you can discuss in one-to-one setup. These are some of the upcoming batches. The 20th, you have some batch launches. You can take a look at some of these batch launches if you're enrolled for a Plus or Iconic, so you can take a look at them. And there is an ongoing batch which started a couple of days back, and with respect to IIFT, especially how to score well in IIFT, there is a discussion on. Yeah, so there is a 6 months, 6 month subscription plan appears to be most preferred one for a simple reason. Probably by the time you hit that hit that March, April kind of month, that's when all your interviews gets done and your results keep flowing in, and you may need guidance as to which B school to join. You might need this kind of subscription plan. That's what is the preferred one. There is an offer available till tomorrow, so you have offers on 3 months pack, which will get 1 month extra, 12 months pack, and you get about 3 months extra if anything suits you. So you can buy one of these plans. You can check out for the prices and buy some of these plans. Yeah, so here we go. And Iconic subscription appears to be a little bit premium, so for a simple reason that there is a lot of time the educators spend with you in one-to-one capacity based on your doubts, etc. Yeah, that pretty much brings us to the end of the announcements. Let's get on to the lecture. Can I quickly know who are all in the discussion? You can put your you can put some, okay, you can exchange the greetings out here so that I will know who is in the meeting. Quickly, could you put something in the chat so that I'll understand who has joined the lecture? Okay, Sristi is here. Good evening, Sristi. Vibha is here. Good evening. Who else? Who else? Just move your fingers quickly on the chat. Quickly put your. Good evening. Good evening, Deepak. Good evening, Harish. Yeah. Anybody else? Anybody else? You can put it out there. Okay. Yeah. All right. Good. Any which ways, right? So when you get the time, so you can go ahead and put this. All right. As usual, let's start with the warm up. So before we get into the actual study, let's start with the warm up so that we all kind of set into it. Keep your book ready. Keep your pen ready. Ensure that you are with your tools and don't be sitting out here passively watching something happening on the screen. If that is the attitude, you can simply move away from it. It doesn't make sense. It doesn't make sense. Education doesn't make sense. It's not about some edutainment kind of, okay, I'm watching the screen, something is happening there. So such attitude doesn't help in learning. So keep your pen, keep a book and sit in an appropriate position for about next 40 minutes or 45 minutes and try to work alongside me. That makes a lot of sense. It's a mental gym. You don't go there in the gym what others are trying to do. You don't get excited by what others are doing. You do something and you get excited about it, right? Yeah. So let's try that. Let's try that. So here is a simple question. Why don't you answer this particular question? Very popular question. Very popular question. Those who prepared for placements, etc., would have come across this particular question. Very popular question in the probability space. Yeah, hi Rishabh. Hello. Yeah, very popular question in the probability space. Why don't you answer this particular question? Good evening, Nazia. Good evening. Go ahead, guys. Answer this. Put answer in the chat. What do you think is the answer for this question? Yeah, I'm waiting for you guys to answer. Put the answer for this question in the chat. Very popular question, right? This is one of the very popular questions. Anyone preparing for placements, or if you're prepared for placements, I'm sure you'll come across this standard question. All right. This is based on calendars. I'm sure all of you understand a little bit about calendars, right? Good. Very good. Very good. It's about calendars. So we know that, hey, just listen. Everybody listen, and it's a warm-up problem. So let's listen and understand, hey, what is the point I want to make out here. Let's come to that point quickly. Yeah, in a calendar, we know that, hey, there are 52 weeks in a year. Technically, we say that 52 weeks. 52 weeks implies that 52 into 7 days, right, which is nothing but 364 days. And hence, when we say if it is a non-leap year, we get one extra day. If it is a leap year, instead of one extra day, we get two extra days, right? There we have two extra days. Technically, in the language of calendars, we call it as odd days. All right, we say that it has two odd days, and these two extra days, because there are 366 days, right? 366 days is nothing but 52 full weeks, 52 full weeks plus two odd days. This is how you remember this, right? 52 full weeks. What do you mean by 52 full weeks? There would be 52 Sundays, there would be 52 Mondays, there would be 52 Tuesdays, likewise there would be 52 Saturdays, right? All of them would come 52 times. There are 52 complete weeks. Doesn't matter the year starts on which day of the week, doesn't matter. There would be 52 Sundays for sure, 52 Mondays for sure, 52 Tuesdays for sure, likewise 52 Saturdays. But there is a chance that 1 or 2 days will have 53 in count in that particular year. Why? It is because of these two odd days. When I say these two odd days, now this question belongs to this odd days. If I look at the answers or whatever, this particular question, it is dependent on 50 this two odd days, because I'm talking about 53 Sundays. Why? 52 is a common feature. 52 is there. It is granted. 52 Sundays are there. 52 Mondays are there. 52 Tuesdays are there. There is no advantage for this 52. The 53rd one is what we are talking about. Now, what can happen on this 53rd day? Technically, all right, 53 Sundays, 53rd, 53rd, I mean the Sunday coming 53rd time, Tuesday coming 53rd time. What is this? When I say look at these two odd days, they have to be two consecutive days. They have to be two consecutive days. You can't say that, man, I have two odd days. One odd day is Monday, the other odd day is Friday. No, odd days cannot be Monday and Friday. If you think one of the days is Monday, the other one has to be Tuesday, right? Similarly, if you think that one of them is Tuesday, the other one has to be Wednesday. Odd days has to be two consecutive days. That's what the two odd days has to be, right? Similarly, Wednesday, Thursday, then Thursday, Friday, or you may say that Friday, Saturday, or it could be Saturday, Sunday, or it could be Sunday, Monday, right? Or it could be Sunday, Monday, Monday, Tuesday, calendar repeats. And hence you say that, hey, these two odd days I can present in 7 ways. 1, 2, 3, 4, 5, 6, 7. When I say that there are two odd days, it's a leap year. When you choose a leap year, it has 366 days. 52, all right, Monday, Sunday comes 52 times for sure. Monday comes 52 times for sure. Each one of these days come for 52 times. Now I'm talking about these two odd days. When you look at these two odd days, I can already permute them in 7 ways. All right, these two odd days can be permuted. In the sense, I can find out that there are 7 different slots for these two odd days. That is what you see it as your denominator. That is what you see it as your denominator. What about the numerator? From the numerator perspective, when you see it, I either want a Sunday or Saturday or Sunday. Fine, I have a Sunday here. I have a Saturday as well as Sunday here. I have a Saturday here, which means 3 numbers are in my favor. Out of 7 metrics, 3 of them are in my favor, and hence my answer is going to be 3 out of 7. But sometimes if I introduce a word here, either, if I write a word either 53 Sundays or 53 Saturdays, then your answer would become 2 out of 7. Why 2 out of 7? This would be out. This will not be concluded. When you say either or, there is a difference. Be mindful about the questions. When the questions were presented in the exam, sometimes they use either A or B. Listen to this very carefully. A lot of people make a mistake here because it's more to do with the grammar. Some people interchangeably use it. Don't use it interchangeably. There is a meaning to this. Either A or B is different from A or B. Either A or B is very different from A or B. What is the difference? When I say either, when I attach this, either A or B means exactly one. Exactly one. A should happen or B should happen. Exactly one. When I don't attach that either, when I simply say A or B, it means at least one. It means at least one. In the sense, when I put this matrix here, say there is A and there is B. A occurred, B did not occur. Case 1. Say this is case 1. Case 2, B occurred but A did not occur. This is case 2. My case 3, if I say that both of them occurred. Case 4, none of them occurred. When I have two events A and B, what can happen? A occurred but B did not occur. B occurred but A did not occur. Both occurred or both did not occur. These are the 4 possibilities. Now, this is true. Let me say that, okay, this is my first question, either A or B. This is the answer for the first question. Case 1 holds true for the first question. Case 2 holds true for the first question. That is it. Case 3, case 4 doesn't come in the picture. However, if I use A or B, then case 1 holds true. Case 2 holds true for the second case. Say this is my second case. Case 2 holds true. Also, case 3 holds true. Case 4 does not hold true. That is the difference. There is a difference between using the phrase either A or B and A or B. There is a difference between them. Be mindful. Check that whether either has been attached or not. Is it simply A or B, or is it either A or B? Difference is either A or B means exactly one. A or B means at least one. Comfortable? Everybody clear about this? Everybody clear about this? Question is clear? Question is clear, everyone? Quickly, why don't you confirm, guys? Why don't you confirm? The warm-up is done. It's a warm-up. It's a warm-up. What I'm trying to teach today is theorem of repeated trials. But before we reach there, let's just warm it up a little bit. Once we warm it, we'll be able to reach that place better, faster, right? Yeah, good. All right. Here we go. Why don't you answer this? Try this out, warm it up a little bit. Why don't you answer this quickly? Try, everybody try, make an effort. Make an effort. Quickly warm it up. Okay, let me give a quick background just in case somebody is not aware of cards. This is what the cards look like. Yes, guys, cards questions have come in the exam. So as a part of warm up, I've taken the cards. Yesterday I did coins and dice. So just as a part of warm up, I'm doing this cards part. Cards are, so if you have a deck of cards, 52, right? 52, you have 26 red cards, we call them. 26 black, we call them red and black. There are 26 which has a kind of a tinge of red, and 26 have a black, right? And on 26 there are two suits. One we call them as diamonds. There is a diamond. The other one we call it as a hearts and diamonds. Hearts and diamonds, they are 13 each suit is 13. This is 13, hearts is also 13. Similarly, under black, we have spade and club. We have spade, which is 13 in number, and we have clubs, which is 13 in number. Right, now each one of these 13, if I just take this 13 figure out here, this particular 13, and this under this particular 13, there are numbered cards. There are numbered cards. Numbers are 2 to 10. 9 numbered cards. Of course, there are 9 numbered cards. There is no number 1. It is 2 to 10. And then you have honors cards. You have honors cards. There are 4 honors cards. What are the honors here? Ace, and there is a jack, and there is a king, and there is a queen. These are the honors cards, right? Yeah. Keep this and quickly answer this question. Answer this question. Same way it is true. This classification of 9 comma 4 is true here also. 9 plus 4, 9 plus 4, all of that. Yeah, I think it should be clear to most of you. Yeah, good. Two cards are selected at random from a well shuffled pack of cards. What's the probability that they are of a different suit? Very good, right? They belong to two different suits. So what is that? Let's say, for example, let's say that, hey, card 1 belongs to heart. Then card 2 can belong to either diamond or spade or club. Hey, how many hearts are there? 13 hearts are there. What about the rest of them? 39. Rest of them are 39. I want one card from here, that is 13C1, and one card from here, 39C1. When I pick two cards, I will be getting 52C2 cards. Right now, this is what happens provided one card is from hearts, the other card is from the either diamond or spade or the club. That is what can happen. Now you may say that, sir, why the first one should be heart? I will change the definition. The first one is diamond, the remaining are heart, spade or club. Remaining one card is from either hearts or spade or club. All right, that's the second case, but answer remains same. Now you may change the definition once again. You may say that I will change it. Hey, this is spade here, the other card is from either the club or it can be from heart or it can be from diamond. So therefore you are trying to say that, hey, this matrix I need to multiply by 4 times, and hence you essentially say that response is 4 into 13 into 39 divided by 52 into 51 divided by 2 factorial, something like this. This is what you kind of write there, right? Yeah, 13 4 times 52, that you cut it off, and then you say that 13 3 times, yeah, 3, yeah, 3 13 times, and then 3 17 times. Therefore you say this, the response to this. Is it making sense what I'm trying to say here? Right, so did I make a mistake somewhere? Just check. Two cards are selected at random from a well shuffled pack of cards. They're of a different suit, right? This is correct, right? Other from 39, that is 1 spade. Or shouldn't I multiply this by 4? 39 by, where am I going wrong? Oh, should we really care about the first one? Yeah, correct. Doesn't matter. 4 is not 4, doesn't matter. Thank you. 4 doesn't matter. Yeah, this case 4 doesn't matter. Yes, you're right. You're right, Rishabh. 4 doesn't matter. Correct, because anyway they are distinct. Yes. Bang on. Yeah. Bang on. Right? Yeah, 13 4 times, then 2 2 times, then you have 13 and 17, therefore 13 divided by 34. None of these. Comfortable? Order is not important. That's right, Harish. Yeah, none of these. 13 by 34. Is it fine, everybody? Is it fine? Clear? Everyone clear? Yeah, okay. Yeah, maybe one last question on warm-up side. Answer this. There is a learning point. Use that example that we did from the Sundays and Saturdays. Use that learning and then apply it here. Use that learning and apply it here. Okay, all right, good. All right, now listen to me here. Okay, so what is that we know? How many clubs I have? We have 13 clubs. Okay, how many honors cards I have? Honors cards are 16. Where are 16 honors cards? There are 4 in each suit into 4 suits. There are 16 honors cards. Okay, so when I'm writing this, listen to me, and there are 4 honors cards out of this which are also clubs. 4 honors cards out of this 16 which are also clubs. There are 4 honors cards which are also clubs. Now here we use the union rule of probability. We use, because there will be a double counting. There are 4 cards which are common here. The 4 cards are also here. There are 4 honors cards which are a part of club are also counted under the part of honors. We need to be a little careful about this. This is where we kind of make a mistake. So what we use here, so this one, already you use that number of elements in A union B is equal to number of elements in A plus number of elements in favor of B minus number of elements in A intersection B. Okay, what if I divide this by total, both left hand side and right hand side? What if I divide this by total? It becomes probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. This is the common mistake people do. At times this is called as the union rule of probability. We also call this as union rule of probability. Nothing but your set theory. You know set theory, whatever the fundamental was applicable there, it is pretty much applicable here, because counting nature remains same, right? There will be double counting. Hey, why in the set theory we used this number of elements in A union B is this? Because there is a double counting, therefore you subtracted. Then isn't there a double counting here? There is a double counting here as well. There are 4 cards which are clubs and honors, and you counted that under honors as well. Therefore come back and subtract it. That's what we are supposed to be doing. So now here this is A is nothing but, let's say that A stands for clubs, B stands for honors, B stands for honors. Therefore probability that it is honors or clubs is nothing but probability of the clubs, that is 13C2 divided by 52C2, because there are 13 cards which are clubs, plus what about honors? 16 honors cards are there. You pick 2 out of those 16 because you are picking 2 cards at random. So total is 52C2. Okay, minus there are 4 cards which you counted both under honors as well as clubs, and hence you got those numbers duplicated, double. So therefore you say that 4C2 divided by 52C2. Okay, you may say that, sir, denominator is common. Why should I write so many times? I'm not concerned about writing so many times. I'm more worried about, hey, did I remember? Do I remember the union rule or not? In the sense, do I remember the set theory formula or not? That is what is important out here. Is this clear? Union rule of probability is clear, everyone? Don't neglect double counting in case if it is there. Clear? Everybody clear? Rishabh? Made sense? Clear? Everybody clear about this union rule? Very important. Wherever you feel that there is a double counting, use this. Use the union rule. Wherever you think there is a double counting, use this and then proceed. Yeah. It's a counting. Ultimately, at the end of the day, it is counting. If there is a double counting, there is a double counting. Come back and reduce it. Yeah. Good. Very good. Yeah. All right. Take a look at this question. This question is just from IIFT, but then similar kind of question has come in CAT, ZAT, in many exams, many times. Yeah. Take a look at this question. Good, guys. Yeah, take a look at this question, all of you. Now let's have some learning from this question now. Let's see what are the kind of learnings we are talking here. Okay, now this depends. Good enough, good enough, good reflection time. You guys have heard about dearrangement? You guys have heard about counting dearrangements? Yes, no? Dearrangement? Yeah, that's right. Heard about dearrangement? Right? Yeah, one of you quickly answer. What is dearrangement for 4? What is dearrangement for 4? What's the value of dearrangement for 4? Quick. What is the value of dearrangement for 4? Okay, what is dearrangement? Okay, let me quickly explain this. Other than Harish, nobody is responding to this. What is dearrangement? For example, If I have, say, all right, now, so A and B are two envelopes. In the first envelope, one should go. In the second envelope, two should go. Let's assume that in the first envelope, you are supposed to keep 1 rupee. In the second envelope, you are supposed to keep 2 rupee. Let's assume like this, right? That's what should happen. Dearrangement means 2 gets into the first envelope and 1 gets into the second envelope. This is called as the dearrangement. All right, yeah, okay. What about 3? Now listen to me very carefully. So A, B, C are 3 envelopes. You are supposed to keep 1 rupee in this, 2 rupees in this, and 3 rupees in this. Understand this carefully, right? You are supposed to keep 1 rupee in the first envelope, 2 rupees in the second envelope, and 3 rupees in the third envelope. Now let me do all possible arrangements, all right, all possible ways of putting money into 3 envelopes called ABC, right? Into these address, ABC or the address, let's say, or name of the people. So I have to put 1 rupee in envelope A, 2 rupees in envelope B, which means named as B, 3 rupees in envelope C. But what are the different ways I can put this? I can put 1 here, 3 here, 2 here, or 2 here, 3 here, 1 here, and then 2 here, 1 and 3 here, then 3 here, 1, 2 here, and then 3, 2, 1. These are the 6 ways. Basically 1, 2, 3 can be placed in 3 envelopes ABC in 3 factorial ways. Nothing but 6 ways. I wrote all these 6 ways out of this. Now listen to me. Dearrangement means none of them. All right, now listen carefully. Kunal, Rishav, don't keep answering that. Leave that. Okay, yeah. So leave that. First listen. Dearrangement means none of the envelopes will get the designated amount of money. That is called as dearrangement. Dearrangement means none of the envelopes will get the designated money. For example, this is my exact case. This is my required case. This is the required case. Now let me write 5 other cases. Case 1, case 2, case 3. This is case 4 and case 5. Case 1 is not a dearrangement. Why? Because 1 is going into the rightly addressed envelope. 1 is supposed to go into A and 1 is going into A. Therefore, 1 is not the dearrangement. 1 is not the dearrangement. Case 2 is the dearrangement. Case 2 is a dearrangement. Why? Because instead of 1 getting into envelope A, 2 is getting into envelope A. Instead of 2 getting into envelope B, 3 is getting into envelope B. Instead of 3 getting into envelope C, 1 is getting into envelope C. Complete mess up, thorough mess up. This is called as dearrangement. Dearrangement and rearrangements are different. Case 1 can also be a part of rearrangement. Case 1 can be some rearrangement. It comes under rearrangement, but it is not a part of dearrangement. Dearrangement means none of the envelopes get the rightly designated money. That is called as the dearrangement. Case 1 is a part of rearrangement. It is not a dearrangement. Case 2 is a dearrangement. What about case 3? Is it a dearrangement or not? You tell me, guys. Is case 3 a dearrangement or not? Yes, no. Is case 3 a dearrangement or not? Case 3. I am talking about case 3. Is case 3 a part of dearrangement or not? Is case 3 a part of dearrangement or not? Not. Very good. Case 3 is not a dearrangement because 3 is supposed to get into envelope C and it is getting into envelope C. 3 is supposed to get into envelope C and it is getting into envelope C. Therefore, it is not a dearrangement. It can be called as a rearrangement. It can be a part of rearrangement but not a dearrangement. Right? Case 4 is a dearrangement. Case 4 is a dearrangement. 1 should get into A but 3 is getting in. 2 should get into B but 1 is getting in. 3 should get into C but 2 is getting in. Therefore, that's a part of dearrangement. Okay, last one. Case 5. Is it a dearrangement or not? Is case 5 a dearrangement? Yes, no. Is case 5 a dearrangement or not? Is case 5, last case, is case 5 a dearrangement or not a dearrangement? Very good. Yeah, it is not a dearrangement because 2 is getting into rightly addressed envelope. Rupees 2 should be placed in B and rupees 2 is getting placed in B. Therefore, it is not a dearrangement. And hence you are saying that if it is 3, alright, if it is for 3 objects, if it is 3 objects, dearrangement for 2 objects is 1. Hey, where is that dearrangement for 2 objects is 1? Here, I proved it here. Dearrangement for 2 objects is 1. Whereas dearrangement for 3 objects is 2. Dearrangement for 3 objects is 2, which is that. This is one case here and this is the second case here. Dearrangement for 3 objects is 2. Now, how do I do that? The proof of this comes from the inclusion-exclusion principle. I'm not giving the proof. I'm giving the formula directly. Try and remember that formula. So, otherwise, if you want to prove this, we have to prove by using the principle of inclusion and exclusion. That is how we can kind of prove this particular part easily. Okay. Now, dearrangement for n things. n things, which means if there are n letters, yeah, n envelopes, and you got to place in every envelope certain amount of money, different money. So that's but then thorough confusion, thorough mess up between this. This is what we call it as a dearrangement. Dearrangement for n things is given by n divided by 2 factorial. You may say that, sir, what if n is 1? Then there is no dearrangement possible, right? Dearrangement is just not possible. So n should be minimum 2. The value of n should be greater than or equal to 2. Otherwise, dearrangement is an impossible situation. Okay, yeah. So n divided by 2 factorial minus n factorial divided by 3 factorial plus n factorial divided by 4 factorial. Keep doing this up to n factorial divided by n factorial. This is what we kind of do. Fair enough. Let me write it here. What is dearrangement for 2? Therefore, 2 factorial divided by 2 factorial. Stop. You can't say that, hey, I will write 2 factorial divided by 3 factorial. No. Stop it at n factorial by n factorial and alternate signs, plus minus plus minus. Okay. This is dearrangement for 2. What is dearrangement for 3? 3 factorial divided by 2 factorial minus 3 factorial divided by 3 factorial. Dearrangement for 4. 4 factorial by 2 factorial minus 4 factorial by 3 factorial plus 4 factorial by 4 factorial, and stop. So if you count them, you understand that, hey, this value is 1, this reference value is 2, this value becomes 9, and similarly when you do dearrangement for 5, that is 5 factorial by 2 factorial, etc., up to minus 5 factorial by 5 factorial. I think that would become 44. All right, that would become 44. Now these are the numbers at least you should remember. Dearrangement for 2 and 3 are not required. 3, 4 and 5. Dearrangement of 3, 4, 5 repeatedly comes in the exam. It is good to remember these numbers 2, 9 and 44. Dearrangement as a concept is clear now. You understood what is dearrangement. Along with that, try to remember this formula also. Right? Proof comes from inclusion exclusion principle. If you are interested, open your 11th standard book and take a look at that. The proof would be there. Right? Because of want of time, we will not get into the proofs in these classes. Right? If you are interested in the proof, sure, 11th standard book. Open your 11th standard higher algebra book. You will have the proof for this. Guys, is this clear? Say yes, no. Only Rishabh is confirming. Others? Was I too fast? You guys have lost. What happened? Others, everybody clear except Rishabh and Vibha, Christy, Suraj, Asim, Kunal, Harish. Getting this? Come back to the question. Good. That's good. Yeah, let's now come back to the question. So what is this question now? That's a background to this question. So let's use this background, how the question has been constructed. Let's take a look. Very good. Very good. Yeah, thanks for that confirmation. Good, guys. Yeah, here we go. A clerk was assigned to place 6 salary increment letters. So as usual, so we'll say that A, B, C, D, E, F. These are the name of the employees. Say letter 1 should go here, not 1 rupee, say call it as a letter 1. 1, 2, 3, 4, 5, 6. These are the 6 increment letters. This is how it has to be placed. All right, this is what the clerk was supposed to do. But instead what happened? All right, now then what is the probability that exactly 2 of them receive their corresponding increment letters? Exactly 2 get the corresponding increment letters, which means there is a mess up between the 4 of them. First we need to decide who are these 2 characters getting the corresponding letters. Let's assume that can be decided in 6C2 ways. Out of these 6 employees, decide which 2 employees got the rightly addressed letter. Okay, say 6C2. Assume that it is A and B got it. A and B got them together. Or say, all right, now these 2 fellows got it. E and F got them together. E and F got it. Anybody for that matter. It doesn't matter. AB got or BC got or AF got. I don't know. That's the reason I wrote 6C2. Some 2 employees got the correctly addressed letters. Assume that E and F got their exact letters. E is supposed to get increment letter 5 and F is supposed to get increment letter 6, and they got it. Okay, so therefore what happened? It is the dearrangement for remaining 4. All right, therefore it is a dearrangement for for remaining 4 divided by, when you place 6 letters in 6 envelopes, your denominator will be 6 factorial. The clerk can put 6 letters in 6 envelopes in 6 factorial ways. Yeah, simplify this. Therefore, you say 6C2. What is the dearrangement for 4? We just now discussed. Dearrangement for 4 is 9 divided by 6 factorial. We got to simplify this. Therefore, 6 into 5 divided by 2 into 9 divided by 6 factorial. I think upon simplification, you get 3 by 16. Am I right? Is this making sense? Clear to all of you? Clear to everyone here? Is this question clear on dearrangement? Clear? Approach is clear. What we meant by this? What I wrote, these numbers are clear. 6C2 dearrangement for 4 and 6 factorial. Yep. Right. Right. Good. Good. Yeah. Super. All right. Let's go to the next concept. Many questions can be created on this. Doesn't matter. By now, you should be kind of comfortable with this. Okay. Here comes a question. Oh, thanks, Risti. Thank you. Yeah. Let's go ahead. Let's take a look at this particular question. Now I'm coming into one concept. This is the main concept for the day. Of course, dearrangement was one of the concepts. And this is another concept. Main concept for the day is this. How do we deal with this concept? Very important concept in probability for exams like CAT, XAT and IIFT. This concept is very, very important. I will tell the concept. First, you look at the question. You look at the question and try make some sense of this question. I will tell the concept later. Yeah, I will leave a minute. Think about it for a minute. You get the answer or not, doesn't matter. Try and understand the question. Wait, Harish. I'll explain this question. Starting point means wherever he is now, that is the starting point. Right? Wherever he's been left is called as the starting point, not the top end or bottom end. Leave this particular question. Now, this is technically built of theorem of repeated trials. How many of you heard about this? Which means, yeah, it sounds familiar. I'm very clear about this. Or should I explain the concept? Theorem of repeated trials or binomial distribution of probability. Either way, some people remember this as theorem of repeated trials or binomial distribution of probability, which is one of the very, very important concept based on which many questions are built in the past. Are you clear? You understood what I tried to say, or should I first explain this concept then come back to this? Theorem of repeated trials or binomial distribution of probability, whichever way you would have learned this in the 12th standard. Is it sounding familiar? Say yes, no. Then I will quickly explain the concept. If it is clear, then we'll go to the question. 2, 3 of you quickly confirm yes, no, whatever it is. Yeah. Right. Yeah, that is one. Success, failure, one. Everybody's clear, Srishti, Vibha. Is this making sense? What we are talking, theorem of repeated trials or binomial distribution of probability. That's clear. So we'll get on to the application here quickly then. Get to the application. Right? Yeah. Starting point means wherever the person is. Not able to recall. All right, not able to recall. Then I may have to go to a different slide. Okay, so all of you, anyway, quickly do this 5 minutes warm up. It's all right. It's all right. If somebody is not understanding, all right, as a benefit of doubt, let me quickly explain. It'll take 5 minutes to explain. So let's read this. All of us, let's try and do this together. There is Alan, who is a trainee soldier, aims and attempts to shoot the target kept at a distance. His gun is loaded with 5 bullets. Probability of Alan hitting the target in any attempt is 2 by 3, 66%. Okay, therefore, what is the probability that he hits the target in the first, second and fourth attempt and misses in the other 2 attempts? Okay, Vibha, understand this. First question, let's see this. Okay, what is happening? All right, now he's taking the target. He's aiming at the target 5 times, right? The first one, first aim. Second time he is aiming at the target, third time he is aiming at the target, fourth time he is aiming at the target, and fifth time the soldier is aiming at the target for 5 times. Okay, what is the probability of hitting? 2 by 3. Probability of the soldier hitting the target is 2 by 3. Therefore, what is the probability of missing? The probability of missing is 1 by 3. That is it, because when you shoot at the target, either you hit the target or you miss the target. There is nothing in between. Either it has hit or it has missed, right? Okay, so therefore hit is 2 by 3, miss is nothing but 1 minus 2 by 3. Total probability minus hit becomes the miss. Miss becomes 1 by 3. Fair enough. So what is author trying to say? The first one is a hit. Second one is a hit here. First one is a hit. Second one is a hit. Fourth one is a hit. What about the remaining 2? The remaining 2 are the misses. Okay, write the probability. What is the probability of hitting in the first shot? 2 by 3. What about this? This is 2 by 3. What about this? This is 2 by 3. What about the remaining? 1 by 3. Missed means 1 by 3. So he has taken aim all 5 times. Therefore, you write this. This is the answer to the first question, right? Simply put, this is the answer to the first question because directions were very, very clear. He has hit in the first shot, second trial and the fourth trial. The remaining trials, he has missed it. Pretty clear, right? Okay. Now, how second one is different from the first one? Let's take a look at the second one. What is the probability that he hits the target in 3 of the attempts? Same thing here. Hey, didn't he hit in 3 of the attempts here? He did hit in 3 attempts here. First attempt, second attempt and the fourth attempt. Then is it not the answer? No, because it can happen that, hey, he might have hit in the first attempt, second attempt, third attempt and missed in the remaining 2 attempts. This is what Rishav can tell, right? And then Srishti may say that no sir, he actually warmed up and then he started hitting in the last 3 trials and the other 2 trials he missed it. Now you say that he lapsed in the concentration. Earlier his concentration was good, he hit, and then because of overconfidence he misses, again he hits, again he misses, again he hits. It like this. Okay, technically you guys are trying to say that, hey, it is the same number you should write, but you got to understand that what are the various ways of permuting this. Then you say that, hey, this permuting can be done in 5C3 ways. Hey, what is 5C3? This is 5C3 is nothing but 10 cases. This is 1 case, this is second case, this is third case. This 5C3 stands for, hey, there are 5 times he is taking the aims. Figure out which 3 he hits out of these particular 5. Okay, 5C3 I will write, and where I will write 5C3 and attach to the earlier result. Whatever was my earlier result, I will attach 5C3 to this particular result 10, because earlier result I did only for the first case. Now you are saying that there is a second case also, there is a third case also, like this there is a 10th case also. So that is what I am attaching now. Attach 5C3 to this. It becomes the answer for the second question. Comfortable? Everybody comfortable? Christy, Vibha, all are clear on this? Clear? Everybody clear? This is all the theorem of repeated trial says. Now let me put the summary in place. Guys, everyone confirm. Is this clear what I'm explaining? Is this clear? Did it make sense? Explanation is clear to all of you? Right. Okay. So therefore, now look at this. If there are n trials, there were 5 trials here. What if there were n trials? Very good. Listen, if there were n trials and I want P success, which means in this case, about 3 times hitting the target, right? P success, right? Okay. Now probability of a success, solid P success I want, or R success. I want R success. So P is the probability of success. P is what? Probability of success. Solid P is probability of success. Q becomes probability of failure. Q is nothing but technically 1 minus P. 1 minus P. Now these would be the 4 ingredients I will have. That's it. I will take n trials. Out of n trials, I want R success. P is the probability of success. Q is the probability of the failure. How do I put it to the perspective? Out of n trials I want R success. Therefore, I will decide which R should be the success, called as NCR, because I don't, that need not be the first three or the last three in this case, just like we discussed. Any three, already 5, n is 5, R is 3, 5C3, any three can hit that. Similarly, NCR. What is the probability of the success? P. How many times I want this success? R times. So just like this here, 2 by 3, 2 by 3, 2 by 3. Didn't we write it 3 times? Yes. So that is what it means. R times I want the success. What is the probability of the failure? Q. How many times it should fail? Remaining times. What do you mean by remaining times? There are n success, n times the trial. R of them are a success. Therefore, what are the failure? Remaining n minus R should be a failure. This is how we write the probability of R successes in n trials. Probability of R successes in n trials is given by this particular statement. Is this clear to you? What I wrote is clear, my friends? Clear? Now, are we good to do the problems? Are we good to do the problems now? You understood this box? This box is clear? All of you got the box? This box is clear. This box is clear. Right. Okay. 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 Yeah. Answer the third question. Answer the third question. Here itself, we did the first two. Answer the third one below that. Answer the third one. Here it is. Just answer the third one. You don't have to type. Just put it to yourself. Answer the third one. Then we'll get into the depth of the applications quickly. Okay, third question is different from the second question. In what sense? Now look at this. What is the probability that he hits the target in 3 of the trials is different from saying probability that he hits for the third time in the 5th trial. These are two different things, right? These are two different things out here. What does it mean to us? Something like this. Listen to this. Aim 1, there is a second time, the third time and fourth time. You got to divide the problem into two parts, A4 and then A5 is a separate one. Between these 4, he should hit exactly 2 times, 2 hits and 2 misses. Only then he will be able to hit for the third time. Then the third hit will come in the 5th trial. Otherwise, it will not come in the picture, right? Otherwise, it will not come. Third time in the 5th trial is possible, provided he has hit exactly 2 times in the first 4 trials. Assume that in the first 4 trials, he has hit already 3 times. In the first 4 trial, he has already hit 3 times. Then where is the question of hitting for the third time in the 5th attempt? That's not possible, right? So therefore, 2 hits in the first 4 trials, the position doesn't matter. Thereby, it leads to the third hit in the 5th trial. Only then. Write it therefore, 2 sample sizes. The first portion, you will say that 4C2, I want 2 hits. What is the probability of a hit? 2 by 3. How many times? 2 times. How many times he should miss? The remaining 2 times. What's the probability? 1 by 3. He misses the remaining 2 times into. Now come back to this. You may say that, sir, for this I will write 1C1. Write it if you are interested in writing. Write it. And then what is the probability of hitting? 2 by 3, because he is hitting here. 2 by 3 raised to power 1. Then you will say that 1 by 3 raised to power 0. Okay, all this drama is not required. You could have directly written it as 2 by 3. There is absolutely no problem there, right? Just write 2 by 3. But some people make a mistake of writing 1 here. Instead of writing all this, what they do is they kind of write 1 as if that fellow is going to hit. He is not going to hit anything. He is not going to hit. You still have to write the probability stating that, man, probability of hitting is 2 by 3. That is it. Clear? Everybody clear about this? Everybody clear? Don't write 1 and all. Don't write 1. Some people write 1 here as if that guy is going to hit. It's only probability we are concluding here. There is nothing certainty here. There is absolutely no certainty. It's only probabilistic study. It's only probability. Yeah, don't make it anything certain unless it's certain. Yeah. Good. All right. Now let me come back to this particular question. Explain a little bit. A man is in the middle of the staircase. So technically what is happening is, on this particular staircase, there are many steps. Let me call this as step number 11. All right, there is a step number 11. There are 10 steps above this. Okay, I'm not drawing 10 lines. I'm drawing some lines. Okay, there are 10 steps below this. There are 10 steps below this. It's saying that there are 21. This is the initial position of the man. This is the initial position. This is where the person is when you observe. This is where the person is. That's what you mean by the starting point. Starting point is we don't know whether he is going up or either is coming down. We don't know. When you found him, he was just standing on step number 11. All right, now which side he is facing doesn't matter to me. He is just there, right? He wants to come down. He may be facing downward. Going up, he may be facing upward. All that story. I don't know which face he is facing, all of that. He is on step number 11. So the question is, he can go up or he can go down. Probability of taking a step upward is 2 by 3. The probability of taking a step downward is 1 by 3, because he doesn't want to come on this side or that side. He doesn't want to go sideways. 100% probability either he goes up or he comes down. So therefore 2 by 3 plus 1 by 3, 100%. The question is, find the probability at the end of 7 steps. He has taken 7 steps, which means he went up, down, whatever it is, 7 steps. He is 1 step away from the starting point. What is the starting point? Starting point should be taken as step number 11. If the clarity was required, I can write in the bracket that take step 11 as the starting point. We can clarify that, no problem, right? Even in the question it can be written. Step 11 is the starting point. We can say that step, which means wherever you observe that man initially, can be treated as the starting point. Question is clear? Everybody, question is clear? Is the question clear now? Is the question clear? Give a quick confirmation that did I explain the question now? If required, in the bracket, take step 11 as the starting point. Wherever you found that man, take it as the starting point. Rishabh, that cannot be possible. See, sometimes I say that in the CAT questions, etc., we have to interpret. Now listen, okay, listen. So in that case, you will also find an answer option that it is impossible. Say, why do I say that? See, if he's in the middle of the staircase, now listen to me, all of you listen to me. So you might have think that the bottom is the starting point. Okay, but it is ruled out. How you can rule it out? How that thought can be ruled out? See, he's saying that you are in the middle of the staircase, which means you are at the center. Middle of the staircase means around step number 11. That's where you are. So after taking 7 steps, is it possible that you will be 1 step away from the starting point if you think that the starting point is the bottom? If you take 7 steps from there, is it ever possible that you will be 1 step away from the starting point if the starting point is considered as the bottom? Not possible. It becomes an impossible situation, but none of the answer options suggest that it's an impossible situation. So therefore auto-correct it. Okay, the moment of truth. So when I found him at the middle, I am taking this particular case as the starting point. So likewise, we have to do certain auto corrections in the exam. We have to do those auto corrections. They would have given us that scope for that auto correction. There is nothing wrong about thinking that, hey, I have taken this as the starting point. No, I have taken bottom as the starting point. There is absolutely nothing wrong about thinking like that. But look at the question, look at the choices and make some auto corrections. Make sense? Is this clear? Everybody clear what I'm talking? Did you get this, what I'm talking? Clear? Sometimes you get these doubts. I also get these doubts. Don't think that only you guys get these doubts. I also get these doubts. But from experience, we know that we have to make certain auto corrections. As simple as that. We have to make some auto corrections to our thinking. Okay, author didn't mean that. He meant otherwise, like this. Okay, so that's the point there. Okay, so now, so when it is possible that he will be 1 step away from the starting point, which means yes, 11 in this case. 1 step away. That is possible provided he takes 4 forward step and 4 upward and 3 downward. If he takes 4 upward and 3 downward, he'll be 1 step away from the starting point. Why? Because there are odd number of steps. Naturally, he can never be at the starting point after taking 7 steps. But I want this fellow to be 1 step away from the starting point. Implies what? 4 up and 3 down, or we can also write this as or 3 up and 4 down. 3 up and 4 down. These are the 2 cases. What is my first case? What if this guy takes 4 up and 3 down? Or this guy takes 3 up and 4 down. Order is not important. In which way he's taking 4 up doesn't matter to me. 4 up and 3 down. Fair enough. So that is what he's doing. So therefore he took 7 steps. Out of 7 steps, 4 of them are going to be upward. So you are writing the binomial distribution of probability on this. Out of 7 steps, he is going to take 4 steps upward. The point is, why you are writing 7C4, sir? Isn't it he will take 1 step up, 2nd step up, 3rd step up, 4th step up, and then he will come back down. Okay, from here one down, all right, one down, all right, now let me use a different color, green color. If from here he comes one down, the second down and the third down. No, it is not like that. Why it should be like that? Why can't it be something like this? All right, why can't it be something like this? It can be like this. Hey, from here he went up and then he came down, again he went up, again he came down, something like that. Hey, we don't know in which order he's doing. Let me write it like this: first step, second step, third step, fourth step and fifth step. It can be up and then down and down. So then he's saying that okay, then another down here, and again he took two ups here. All right, now he took ups here. He took two ups, then he took consecutive three downs, and then again he took two ups. That is also fine. He'll be one step away from that. How do I represent this thought? By 7C4. That's the reason I'm writing 7C4. This is one case out of 7C4 cases. Therefore, I should first write this 7C4, because when I said that 4 up, I never meant that there are 4 consecutive ups followed by 3 consecutive downs. No, I don't know. So it could be like that as well. One of the cases can be like that as well. One of the case can be, hey, it is up and then down and down. The other case could be up down and up. So I don't know. Like this, there are many cases. All those cases I'm representing it as 7C4. That is the representation of 7C4. Hey, what is the probability of going up? Probability of going upward is 2 by 3. How many times? 4 times. Okay. Probability of coming down 1 by 3. How many times? 3 times. Plus. Or means plus. Fundamental principle of counting. Or means plus. Okay. Write the second side of the story. 3 up. Therefore 7C. 3. Probability of going up 2 by 3 raised to power 3 and 1 by 3 raised to power 4. Now this gives me the result for this particular question. Comfortable? Everybody clear on this? Give a quick confirmation that you understood what we wrote. Simplification later. You can simplify this later. Is this clear what we discussed? You understood each element, what I meant by 7C4, what I meant by 2 by 3, what I meant by 1 by 3. Are all these numbers clear? The logic clear? Once we get the logic behind the question, once I write this statement, how do we present this thought? We have to start by writing 7C4, or we have to start by writing 7C3 and present this thought. Clear, everybody? Good. Guys, give little more confirmation here other than Rishav, Harish, Asim, Sristi. So if you are with me, I hope you are not lagging. Put it to be at the live, be alongside me and give more confirmations. That is always encouraging. That sends me that, so that I understand that okay, you guys are able to follow what I'm trying to say. You are not lost on your way, right? Yes, here is another question. Same concept, another question. Take a minute and try and write the answer for yourself, even if it is difficult, painful to type it, doesn't matter. Yeah, good Chinmay. All right. Yeah, try this question, everyone. Try this. Yeah, let me break this question. Put it in the chat. How many cards are in favor of event E? How many cards are in favor of event E? You understood event E, right? Event E is understood. What is event E? Event E occurs if and only if the product of two digits of the selected numbers is 12. How many cards are in favor of event E? First you give me that. How many cards are in favor of event E? How many cards are in favor of event G? How many cards? How many cards are in favor of event G? How many cards? Right. How many cards are in favor of event? You are picking only one card. Yeah, there are 100 cards. One card is 00, another card is 01, another card is 02. Guys, these are the cards. All right, what are the cards? Each card has a 2-digit now. All right, each card is a 2-digit code, 01, 02, 03, like this up to 99. These are the cards. What is the product of the numbers on the cards? 0 into 0, 0, 0 into 1, 0, 0 into 2, 0. Like this last card, I can write it as 9 into 9, 81. This is what you mean by product of the cards. This is what author is trying to say. Now, which cards he wants? He wants a card on which the product becomes 12. Product of the 2 digits. Product of the 2 digit, not 2 cards. Cards are this. Cards are numbered as 0001. Product of the 2 digits printed on that card should become 12. Which are the cards in my favor, therefore? Alright, the cards in my favor are 26. Alright, 26, then you write 2 into 6, which becomes 12. Of course, naturally, if 26 qualifies, 62 also qualifies. Somewhere here would be 62. So where would have written 2 into 6, 6 into 2, which also becomes 12. That is one pair. Okay, the other one, 34. 34 is nothing but 3 into 4, which becomes 12. The reverse also will be possible. That is 43 card number. 4 into 3 also becomes 12. That is it. These are the only 4 cards. These are the only 4 cards out of 100 cards. From 00 up to 99, there are 100 cards. Probability of event E is nothing but 4 cards are in my favor out of 100 cards. You say that 1 by 25. That is the success. This is the probability of success, which we called it as small case P. Or let small case P in the binomial distribution of probability. This is what I called it as a P, 1 by 25. Therefore, what is the probability of not getting the event? When I pick any card in random out of these 100 cards, I simply pluck one card at random. What is the probability of non-occurrence of this particular event? Of course, if this is 1 by 25, this is going to be 24 by 25. It is going to be 24 out of 25. This is what we called as Q. So now in this question, you have to determine the P and Q. Before you do anything, you got to determine this particular part called as P and Q. This is what you are doing. Okay, fair enough. Now what is the question? Coming to the question, P I am ready, Q I am ready. Question is, if 4 numbers are selected at random, find the probability that event E occurs at least 3 times, which means probability of event E occurring 3 times. Or probability of this particular event occurring 4 times. Probability of this event occurring 3 times or probability of this particular event occurring 4 times. Now what do you mean by this event should occur 3 times? There are 4 cards in your favor. Here these are the 4 cards in your favor. You want 3 out of these 4 cards. Which 3? I don't know. You may get 26, 34 and 43 or any combination of 3. I want 3 cards out of these 4 cards. Or then what is the probability of getting such particular card out of these 4 cards? So you say that, hey, this is nothing but, therefore you are writing this as 1 divided by 25 raised to power 3. Then you say 24 divided by 25 raised to power 1 plus. Yeah, I want all 4 cards which are in favor of this particular event. Then you say that, hey, this is 4C4, 1 divided by 25 raised to power 4, 24 divided by 25 raised to power 0. This is the answer to this particular probability question. Is this clear to you? Is this clear? Rishabh, it is not 100C4. It is not 100C4. It is about these particular 4 cards. If 4 numbers are selected, already that probability of 100 is taken care in terms of P and Q, Rishabh. So you may wonder what happened to that 100. That has been already considered in P and Q. When you wrote that P, you already took that 100. You already took that 100. That 100 has already been a part of P and Q. You don't have to now consider that 100. You don't have to duplicate that 100 once again. When you wrote that event 4 by 100, you already took the complete total space. You again don't need that 100. You again don't need that. Right? When it is at least 3, what do you mean at least 3? You got to get 3 cards out of this. See, you are not writing numerator, denominator, my friend. Be careful. You are not saying that my numerator is a favorable case, denominator is the total case. Where is favorable and total? You are already expressing this. All it in terms of probabilities. You are writing the composite probabilities as a part of in terms of probability. And while calculating that probability, already 100 has been considered. Clear? Got it? Crystal clear? You are not using the basic definition, favorable by total. You are not using that definition. You are not using the definition anymore. The definition has been already used here. 4 by 100, 96 by 100. You are writing the composite probability in terms of probability itself. I hope there is a clarity. Everyone, confirm. Is there a clarity in what we are discussing? Parth, I think whatever I have to repeat, I repeated. You would have understood this 100 here, then the game is done. You got to understand that 100 has been already considered. You don't have to think about that 100 and write here as 100 C4. Not required. You are not writing favorable by total. You are writing the composite probability as probabilities from the function of probabilities. Good, very good. That's another mistake people do. They forget to understand that point. Okay, here we come. One of the beautiful ZAT questions. Take a minute, friends. Try and interpret this question. Very beautiful question. Yeah, all these are 11th standard probability question. Basically, if you have done your 11th standard and had you studied this subject clearly there, and if you remember, you study and you kind of remember. Yeah. All right. How do I represent this thought? Assume that they have to play n matches. India has to play against Australia n matches. Okay. If they play all n matches, listen, everybody listen carefully. This is one of the very important concepts, right? The way, because people kind of tend to forget how to approach this particular question, right? Say they have played n matches. What is this thought? First of all, they played n matches. What can happen in n matches? India may win 0 matches. India won 0 matches. Possible when they play n matches. I mean, let's write all possibilities. They played n matches. Whitewash. Australia has beaten India black and blue in football. Say, yeah, or 0 matches. Or India might have won 1 match. I'm writing from India perspective. I'm analyzing, keeping India in mind. India might have lost all the matches, 0 matches, or India might have won 1 match, or India might have won 2 matches, or India, probability of India winning 3 matches, or 3 wins. Likewise, India can win all n matches. There is no problem. This can happen as well, right? All matches. This is what can happen. This is equal to total probability called as 1. If the India has played against Australia n matches, the point is I want to find out what is this n. That is the whole idea. What is this n? That is what we need to find out. Sure, we will find this out. No problem about it. We will find this out, right? Yeah. So, but then when they played n matches, what are the possibilities? India might have won 0 matches, or they might have won 1 match, they might have won 2 matches, or they might have won 3 matches, or they might have won all the matches, which is nothing but the total probability called as 1. Okay. Now, what is author interested in? Author is interested in this. Author is interested in this bracket. He is saying that India should win at least 1 match. Here, probability of India winning at least 1. Author is saying at least 1 match. At least 1 match means which bracket? Here, India should win at least 1 match. 1 match or 2 match or 3 match or winning n match. All that is part of the at least 1 match. He is saying that, hey, look man, this part of the probability should be more than 50%. This should be greater than 1 by 2. Total is 1. Out of total 1, this part, underlined part, should be greater than 1 by 2, which implies this particular part should be less than 1 by 2. This particular part should be less than 1 by 2, because see, sum is 1. Sum is 1. Out of sum is 1, if the underlined portion, this underlined portion, the green one, I'm going again. So this underlined portion is greater than 1 by 2. Author said that it should be more than 50%. I'm writing 50% as a fraction, greater than 1 by 2. Okay. Then what should be the value of the number outside the bracket? It should be less than 1 1 by 2. All right, it should be less than 1 by 2. For example, hey, this is 0.8, fine, then this is 0.2, something like that, but I don't know. So that is what the idea is. So far, are you guys clear what I'm doing? Guys, so far, are you clear what I did? So far, is this clear? So far, is this clear? What I explained so far, is this clear? This step is clear. So far, these steps are clear. Right? Right, just focus on this. So therefore only answer this question. Why you want to answer the rest of the part? Just answer this particular part, because if this part is satisfied, then this part is automatically satisfied. Therefore you look at this particular question, you say that probability of India winning 0 matches should be less than half, which is nothing but saying that probability of India winning at least 1 match should be greater than 1 by 2. That is what author asked you. So you are converting this question into this. You are saying that probability of India winning 0 matches should be less than half, implies probability of India winning at least 1 match, implies probability of India winning at least 1 match will be greater than 1 by 2. So simply focus on this and resolve this particular issue. What is the probability of India winning 0 matches? What is the probability of India winning 1 by 6? Therefore, what is the probability of India not winning? Probability of India not winning is 5 by 6. 5 by 6 raised to power how many? All at 5 by 6 raised to power n should be less than what? Should be less than 1 by 2. When they played n matches, India has lost every single match. Probability of 0 wins. Hey, where is this coming from? They played n matches. You can write this NC0. India should win 0 matches out of this. Probability of winning is 1 by 6. 1 by 6 raised to power 0. 5 by 6 raised to power n. If you want me to complete the thought looks like this, which is less than half. This is what you mean by probability of India winning 0 matches out of n matches. NC0, which means India is winning 0 matches. And therefore, you will say that 1 by 6 is the winning rate, probability of winning, raised to power 0. 5 by 6 raised to power n. Therefore, you simply say that 5 by 6 raised to power n should be less than half. So keep plugging the values and determine the answer. Okay, so far are you clear? Did you get to this particular stage? 5 by 6 raised to power n is less than 1 by 2. Is this clear? Is this clear? 5 by 6 raised to power n is less than 1 by 2 is clear, everybody? I just told you that if it is a complete binomial distribution, this is how it looks. But some things you don't have to write in the exam, because this value is 1, this value is 1. So value of 1s, you kind of ignore it, is in your mind, you don't have to present it on the paper. Right? So then keep plugging the values. Hey, let n is equal to 1, n is equal to 2, n is equal to 1 is 5 by 6. If n is equal to, in the exam, this is what runs in your mind. If n is equal to 1, 5 by 6. 5 by 6 less than 1 by 2. No. Okay, put n is equal to 2. 5 square by 6 square. 25 by 36. Is this less than 1 by 2? No. Okay, put n is equal to 3. No, you don't have to do all this. I'm just telling you how do you evaluate this. No choice. If there are answer choices, do the answer choices. If it is a theta question, you will plug it like this and you will check n cube. That is 5 cube is 125. 6 cube is 216. You still say that this is not less than 1 by 2. Answer is no. Put n is equal to 4. You write this as 625. And then you will be writing this is 1296. Is this less than 1 by 2? Yes, this is less than 1 by 2, because if this is 625 here, 625, half of this means this has to be 1250. 625 by 1250 is equal to half, but your number in the denominator is more than 1250. Therefore, you know that this is less than half. Your answer is yes, and hence you say that India should play at least 4 matches to have a success rate of winning at least 1 match, to at least win 1 match against Australia. So India should play at least 4 matches in that particular series. Comfortable? Everybody clear about this question? All of you are clear about this question? The way it is worded, did it make sense? Everyone, give a quick confirmation that did it make sense? This is one of the good questions on binomial distribution of probability. Yeah. Okay, now can I consider that you got a kind of hang of binomial distribution of probability or theorem of repeated trials? Everybody give a confirmation that yes, this part you understood very well. Clear? This part is clear? right? Okay, in the next lecture, what we do is we apply this binomial distribution of probability with conditional probability. That is the next one, right? Which kind of comes in the exam, conditional probability. Put binomial distribution of probability along with the conditional probability. We will scale to the next level. That will take us to the next level, because a lot of people get confused with conditional probability, and when technically we merge binomial distribution of probability with conditional probability, it tends to be much more trickier. All right, it tends to be much more trickier. We will try and evaluate that in the next lecture. We will try and first understand conditional probability in the first half of the lecture. In the second half of the lecture, we will merge these two elements and we will try to discuss this, right? Yeah, we'll try to discuss this. Okay, yeah, so that's what we kind of do. All right, so that brings us to the end of today's lecture. So what is coming up next? What is coming up next is tomorrow will not be meeting on the YouTube instead. So because there is a little bit of algebra we are doing on the other side, so we will focus on algebra. We will do tomorrow on the special class app. We will do it on the app, special class app, between 5 p.m. and 6:30 p.m. 90 minutes lecture. We'll do 90 minutes. So we will cover a little bit of algebra. We were doing some algebra because in between I was kind of not available, so we kind of halted it. So join me there tomorrow at 5 to 6:30 p.m. I think the lecture should be reflected on the app. Today itself you can kind of schedule that particular lecture. You mark on that particular lecture. The moment we start at 5 o'clock, you kind of receive a notification that we'll do it tomorrow. As a part of algebra, two things we will discuss: inverse functions. Did we discuss inverse function, Rishabh? Some of you, Rishabh, Srishti, you guys attend very regularly. So just confirm, did we discuss the questions on inverse function? I always put it on the slide, but somewhere I think that I'm missing out to discuss that. We didn't, right? Yeah, okay, so we'll do that. We will do that, and along with that we will also try and do maxima minima in terms of equations, right? Yeah, we'll do this. So we'll try and cover two themes in 90 minutes tomorrow. So tomorrow we'll not be doing on YouTube. Instead, tomorrow we'll be doing the lecture on the app, Unacademy app. So the lecture has been already presented. Just click on that so that you will be notified once we start the lecture. Day after tomorrow, that is Thursday, we will come back and continue this particular study. Thursday we will do the conditional probability, then mix up some other elements along with the conditional probability. This is what is coming up. And anybody is on the Plus platform, I'm doing lectures on IIFT algebra. You can join me there. 2 lectures I finished. Tomorrow I'll be doing the next one, so you can join me on that. So if you're on the Plus platform, join me there. All right, we are doing some fantastic study, so you can join. Okay, so here we go. So before you conclude, if you have liked the lecture, press the like button before you leave, and you can share the link with your friends as well. Subscribe to the channel, thereby whenever we start the lecture, all that you will kind of get to know about it. Yes. And this particular weekend, if you guys are taking the test, 24th, take this particular test. 7th, one test was done. One of the tests was done. Analysis should be available by tomorrow. On 24th, you can join for another test. So every Sunday, I keep asking you to write a test. It doesn't matter if you're not taking the test regularly. On Sunday, you can attempt this particular test out here, and you can take the regular test on some other day. Yeah, that pretty much brings us to the end of the discussion. Any questions, you can present it now. And those who are watching offline, you can put your comments in the comment section. Yeah, at a later stage. Yes, any questions you can ask me. Otherwise, we are good to wind up. Those who are winding up, good night. Stay blessed. I will see you guys tomorrow on the Unacademy app, and day after tomorrow back on the YouTube. Yeah, bye till then. Yes, anybody, any question to be presented at this time, you can ask. Your time, you can ask me. I will take a couple of minutes and respond. If no question, tata, bye-bye. Welcome, Harish. Welcome. Bye-bye. Good night. Good night, guys. Good night. All right. Looks no question. I'm closing. I'm signing off. Goodbye to all.